The power goes out at 2 in the morning, and by the time morning rolls around, your smart home has amnesia, automations stalled, mesh networks fragmented, everything waiting for you to manually piece it back together. A good UPS doesn't just keep the lights on, it protects the invisible intelligence you've carefully built into your walls. I'm Keiko Tanaka, and I specialize in making smart home tech disappear into the architecture of your life so it works seamlessly without announcing itself.
You're listening to the Smart Home Setup Podcast. Quick note before we dive in. The research, data, and script you're hearing are fully human verified and written by real authors who know this stuff inside and out. The voice delivering it, though, that's AI generated. Just want to be transparent about that from the start. If you've been listening for a while, genuinely appreciate you being here. And if this is your first episode, welcome. Glad you found us. New episodes drop every Monday, Wednesday, and Friday. Now, here's what we've got for you today.
Finding the right uninterruptible power supply for your smart home hub means matching battery capacity to what your protocols actually need, understanding how Zigbee, Z-Wave, and Matter controllers recover when power cuts out, and making sure your automation keeps humming along even when the grid doesn't. Quick take, the CyberCower CP1500PFCL-CD delivers pure sine wave output with enough runtime for multi-protocol setups, while the APC Backups Pro 1500 VA offers solid value if your setup leans simpler. Think Wi-Fi and Zigbee without the added complexity. Now, what should you actually look for when you're shopping for one of these things? Start with the type of power it puts out. Most smart home hubs, especially ones managing Zigbee, Z-Wave, or Thread mesh networks, have sensitive electronics inside. They don't respond well to simulated sine wave output, which is basically a stepped approximation of real power. Pure sine wave output mirrors what comes out of your wall outlet. It prevents that low hum you sometimes hear, extends the life of your devices, and keeps your controllers from crashing unexpectedly. If you're running a Zigbee hub like a Philips Hue Bridge, SmartThings, or Home Assistant with Zigbee Coordinator, or a Z-Wave controller like the AOTech Smart Home Hub or Hubitat Elevation, or even a Matter over Thread device like an Apple HomePod Mini or Google Nest Hub Max with Thread support, you want pure sine wave, no question. If your setup is just Wi-Fi smart plugs, cameras, and voice assistants without any mesh coordinator responsibilities, simulated sine wave might work, but pure sine is still better for the long haul. Next, think about runtime. Battery capacity alone doesn't tell the whole story. What matters is the load to runtime ratio. A typical smart home nerve center pulls somewhere between 50 and 150 watts continuously. A Zigbee hub might draw 5 to 10 watts, a Z-Wave controller 3 to 8. Your Wi-Fi router may be 15 to 25 watts depending on the model. Cable or fiber modem 10 to 20. An 8-port managed network switch another 8 to 15. A Matter border router embedded in your hub adds almost nothing. If you're running a NAS or local server for automation software, that's anywhere from 30 to 80 watts. Add it all up, and a 1500 VA UPS with 900 watt-hours of capacity running a 100-watt load gives you roughly 6 to 8 hours of runtime. That's enough to ride out most regional outages and give you time for automated shutdown sequences if things drag on longer.
Then there's switchover latency, which is how long it takes the UPS to kick in when the power drops. This determines whether your mesh network experiences a tiny blip or a total collapse. Zigbee and Thread networks can tolerate interruptions of 10 to 20 milliseconds without dropping connections. Most line interactive UPS units transfer in 4 to 8 milliseconds, well within that tolerance. You shouldn't see any disruption to your automations. Z-Leave networks are slightly pickier about voltage sag. Keep transfer times under 10 milliseconds and you'll avoid controller reboot loops. Wi-Fi and Matter over Wi-Fi are a different story. Routers and access points take 30 to 90 seconds to reboot if power drops completely. A UPS prevents that, but if your backup power plan includes a generator with an automatic transfer switch, you've got to account for that 10 to 15 second switchover gap. Your UPS needs to bridge that window. One thing to keep in mind, if the power outage outlasts your UPS runtime, most hubs default to their last known state rather than just shutting everything off. It's smart to configure fallback automations so that when power comes back, your devices resume their routines intelligently instead of all trying to reconnect at once and flooding the mesh. Form factor matters more than people think, especially if you care about design. In a well-thought-out space, a UPS either becomes furniture or it disappears. Tower-style units, vertical orientation, 6 to 8-inch footprint, fit inside credenzas, behind media consoles, or tucked into custom millwork. Rack-mount UPS systems are great for dedicated equipment closets, but they scream industrial. There's also the thermal reality. UPS batteries generate heat when they're charging and discharging. If you enclose one in a cabinet without ventilation, you're shortening the battery's lifespan and risking thermal shutdown. If you're hiding the UPS, make sure there's at least 2 inches of clearance on all sides for passive airflow, rear venting or louvered panels if it's enclosed in millwork, and keep the ambient temperature below 77 degrees Fahrenheit. Every 15 degrees above that cuts the battery life in half. I've recessed UPS units into mudroom cabinetry, closet baseboards, even beneath raised flooring in home offices, anywhere air moves naturally without needing forced circulation. Modern UPS units can talk to your hubs and servers via USB or Ethernet, which enables graceful shutdowns when battery reserves drop below safe levels. Imagine an automation that says, if the UPS battery level falls below 20%, send a notification through your Matter-enabled smart speaker saying, "Power outage detected, battery low." Then it disables non-essential automations like landscape lighting or decorative scenes, triggers a graceful shutdown sequence for your NAS, but keeps the critical devices running: security cameras, door locks, climate sensors. Most UPS network management cards support SNMP, HTTP, and SSH access, so you can integrate them with Home Assistant energy management automations or SmartThings custom device handlers. Just verify your hub's software actually supports UPS monitoring. Habitat and Home Assistant do. Some proprietary ecosystems like Google Home or Alexa don't, at least not natively. Battery replacement is another thing people overlook. UPS batteries degrade whether you use them or not. Lead-acid cells, which are the most common, last 3 to 5 years. Lithium-ion alternatives are rare in consumer UPS units, but they can stretch to 8 to 10 years. They also cost 3 to 4 times more upfront. Here's the hidden cost. Replacement battery packs for name-brand UPS units often run 40 to 60% of what you paid for the original unit. A $300 UPS with a $180 battery replacement every 4 years actually costs you $345 over a decade when you amortize it. Budget for that, or think about whether it makes more sense to put that money toward a whole home solution instead. All right, let's get into the specific units worth considering.
The CyberPower CP1500 PFCL LCD is the most versatile choice for multi-protocol smart homes. Check the link below to see the current price. It delivers 1500 VA and 1000 watts of capacity with true sine wave output, which protects sensitive Zigbee, Z-Wave, and Matter controllers without the electrical noise that can degrade mesh reliability over time. The LCD panel on the front gives you runtime estimates and load percentages, real data points instead of abstract guesswork during storm season. You get 12 total outlets, 6 with battery backup plus surge protection, 6 with surge protection only. That's enough for your router, modem, primary hub, secondary protocol bridges, NAS, and network switch. It has USB and serial connectivity for automated shutdown scripting with Home Assistant or Habitat. The tower form factor, 12.5 inches by 7 by 10.5, fits inside most media consoles or equipment cabinets. The audible alarm can be silenced without disabling monitoring, which is critical if it's going in a bedroom or open-plan living space. You're looking at 8 to 10 hours of runtime at a 100-watt load, which covers a typical Zigbee plus Z-Wave plus Wi-Fi setup. Downsides? The fan activates during battery mode and produces a noticeable hum, somewhere around 45 to 50 decibels. Plan to install it away from seating areas or bedrooms.
Replacement batteries cost around $140, so long-term ownership isn't cheap. And at 43 pounds loaded, if you're wall-mounting it, you need structural support beyond typical drywall anchors.
The APC Backups Pro 1500 VA is a practical middle ground if your home prioritizes Wi-Fi and Zigbee devices without the full complexity of mixed Z-Wave and Thread networks. Check the link below to see the current price. It uses simulated sine wave output, which works fine for modern router hardware and Zigbee coordinators, though I've seen occasional voltage sag with older Z-Wave Gen 5 controllers during extended runtime. You get 10 total outlets, 5 with battery and surge, 5 surge only, which suits typical smart home peripheral loads. USB monitoring integrates seamlessly with Synology NAS and most Linux-based automation servers. It has reliable automatic voltage regulation, which smooths out brownouts without switching to battery, extending the lifespan during unstable grid conditions. It's also significantly quieter than the CyberPower during normal operation, under 40 decibels. The warranty even includes battery replacement for the first 3 years, which is uncommon at this price point. On the downside, that simulated sine wave occasionally causes a faint coil whine in AOTech Z-Wave controllers and older Philips Hue bridges, the Gen 1 and 2 models. The front-facing USB charging ports create visual clutter if the unit isn't fully concealed, and it's heavier than the spec sheet suggests, 52 pounds, due to a larger transformer, so factor that into your furniture placement. The Trip Lite Smart 1500 LCD TA is designed for installations where the UPS has to remain visible. Check the link below to see the current price. Its matte black finish and subtle LCD integrate better into contemporary interiors than the aggressive industrial styling you see on competing units. Performance-wise, it mirrors the CyberPower's pure sine wave output while adding Ethernet and USB-C monitoring options that simplify integration with Matter over IP ecosystems. The power delivery is exceptionally clean, measured at less than 3% total harmonic distortion. Ethernet-based monitoring with SNMP version 3 enables integration with professional home automation systems and commercial-grade network management tools. 12 outlets arranged in 2 banks let you set up separate load prioritization, critical devices on bank 1, discretionary on bank 2. The LCD panel even includes estimated carbon offset data, which is a subtle nod to energy-conscious households. The vertical tower orientation has cable management channels that reduce visual tangle. Downsides? Replacement batteries are brand-specific and harder to source regionally than APC or CyberPower equivalents. The LCD brightness can't be dimmed or disabled, so it creates light pollution in darkened rooms. I've resorted to opaque tape or strategic angling, and the cooling fan runs intermittently even when it's on utility power during high load periods, which breaks the silence in quiet homes.
The APC Smart UPS SMT 1500C with Smart Connect targets serious automation enthusiasts running local servers, extensive Zigbee mesh networks with 30-plus devices, and multi-protocol bridge configurations that demand rock-solid uptime. Check the link below to see the current price. The cloud-connected monitoring feels a bit paradoxical in a device meant to survive internet loss, but the data insights during normal operation help inform better energy management decisions. Pure sine wave output with line interactive topology and exceptionally fast transfer time, 2 to 4 milliseconds. The Smart Connect module provides cloud-based UPS health monitoring, runtime predictions, and automated support ticket generation. The LCD has customizable thresholds, so you can set specific battery levels that trigger automation sequences. Hot swappable batteries mean you can replace them without powering down connected equipment, which is critical if you're running security camera NVRs 24/7. 3-year warranty with next business day advance replacement. Downsides are the premium pricing, which reflects enterprise features most residential users will never configure.
Cloud monitoring requires a constant internet connection, creating a single point of failure for status visibility during outages. The tower design measures 7 by 17 by 23 inches, making it too large for standard furniture concealment. You really need a dedicated equipment closet. And the audible alerts default to aggressive beeping. You'll need custom scripting to redirect notifications to smart speakers or phones.
The Amazon Basics Standby UPS 800 VA serves minimalist setups with a single Zigbee or Wi-Fi hub, router, and modem. Nothing more. Check the link below to see the current price. Its simulated sine wave and modest capacity make it unsuitable for complex, multi-protocol environments. But if you're just beginning to understand why smart home devices lose connection during power failures, it offers an accessible entry point. It's the lowest cost per watt in this category, often under $100. Compact footprint, 10.9 by 6.3 by 4.7 inches, disappears behind furniture without dedicated planning. 12 outlets, 6 with battery and surge, 6 surge only, which provides adequate coverage for small-scale installations. No fan, so it's genuinely silent during operation. Indicator lights are subtle and positioned on the top panel rather than front-facing. Downsides? 800 VA and 450 watts of capacity delivers only 1 to 2 hours of runtime under typical smart home loads, which is barely sufficient for brief outages. Simulated sine wave causes measurable voltage instability with sensitive devices. I wouldn't recommend it for Z-Wave Plus or Thread border routers. No network management interface, no USB, no Ethernet, no automated shutdown scripting. And battery replacement requires complete disassembly, which voids the warranty on first-generation units. The CyberPower OR1500 PFCR-T2 solves the form factor dilemma for homes with dedicated equipment racks or custom server closets. Check the link below to see the current price. It delivers pure sine wave power in a 2U rack mount chassis that integrates seamlessly with professional-grade network hardware. If you've invested in a proper home automation nerve center where all protocols converge in a single ventilated space, this UPS becomes invisible infrastructure. Rack mount format at 2U height integrates with standard 19-inch racks alongside network switches, patch panels, and PoE injectors. Pure sine wave output with exceptional voltage regulation across all outlets. Front panel LCD with rotation capability for inverted rack mounting. 10 outlets with individually configurable load shedding via network management card. There's even an EPO port, emergency power off, which allows integration with fire suppression or environmental monitoring systems. Downsides? It requires 2U of rack space plus 2 inches of rear clearance for cable management, which isn't feasible for homes without dedicated equipment areas. Rack ears and mounting hardware are sold separately, adding unexpected cost. Fan noise, 50 to 55 decibels during battery mode, necessitates acoustic isolation or placement in non-living spaces. And at 60+ pounds installed, your rack needs proper weight distribution or it risks tipping. Now, a few questions people tend to ask.
How long should a UPS run a smart home hub during a power outage? A properly sized UPS should sustain your critical smart home infrastructure, hub, router, modem, and primary mesh network coordinator for at least 4 to 6 hours. That covers most regional outages and allows time for automated shutdown sequences if the interruption extends beyond that. The exact runtime depends on your total connected load. A typical Zigbee hub drawing 8 watts, plus a Wi-Fi router at 20 watts and a modem at 15 watts, pulls about 43 watts total. A 1500 VA UPS with 900 watt-hours of usable capacity delivers roughly 15 to 18 hours of runtime before it depletes. For configurations that include local servers, NAS storage, or multiple protocol bridges, Z-Wave plus Zigbee plus Matter, expect runtime to drop to 6 to 10 hours.
Rather than targeting a specific duration, design your backup power strategy around your home's typical outage patterns. If your region experiences frequent 1 to 2 hour interruptions, a 6-hour UPS gives you comfortable overhead. If multi-day outages are common, pair UPS protection with generator or whole home battery integration and configure the UPS to bridge the 10 to 15-second transfer gap rather than sustaining indefinite runtime. Do Zigbee and Z-Wave devices need pure sine wave UPS protection? The hub needs it, the devices don't. Zigbee and Z-Wave mesh networks consist of two distinct power layers: the central coordinator, your hub that manages routing tables and protocol translation, and the battery-powered or mains-powered endpoints like sensors, switches, and plugs distributed throughout the home. The coordinator contains sensitive microcontrollers and radio transceivers that respond poorly to the voltage distortion inherent in simulated sine wave UPS output. You can get intermittent resets, mesh table corruption, or accelerated component degradation. Pure sine wave power, which is identical to utility-supplied AC, eliminates these risks entirely. The endpoint devices themselves, motion sensors, door locks, smart plugs, typically run on battery or have internal AC to DC converters robust enough to tolerate simulated sine wave if they happen to be plugged into UPS-protected outlets. That said, you'll rarely power endpoints through a UPS anyway. Zigbee 3.0 coordinators and Z-Wave Plus controllers both specify clean sinusoidal input for rated lifespan. Matter controllers built into existing smart speakers or displays inherit the parent device's power requirements. HomePod and Google Nest devices prefer pure sine wave for longevity, though they'll function on simulated waveforms.
Yes, with a few caveats around protocol and placement. A Wi-Fi or Zigbee smart plug with energy monitoring capability, like the AOTech Smart Plug 7 for Z-Wave or Third Reality Matter plug for Matter and Thread, can track when utility power fails and battery backup engages. That creates useful automation triggers, like if the plug power source equals battery, then disable non-critical automations. However, physically connecting the plug between the UPS and a protected device introduces an unnecessary failure point and additional standby power draw. Smarter integration involves using the UPS's native USB or network management interface to surface power status directly to your hub. Most modern automation platforms, Home Assistant, Habitat, SmartThings with custom handlers, can query UPS status via Network UPS Tools, or SNMP, surfacing metrics like battery percentage, load wattage, and estimated runtime. If your UPS lacks network connectivity, then yes, a strategically placed smart plug works as a workaround, but choose one with minimal standby draw, under 1 watt, to avoid reducing overall runtime. Place the monitoring plug on a non-battery outlet so it immediately loses power when utility fails, creating a binary state change your automations can detect. What happens to Matter devices when the Wi-Fi router loses power without a UPS? Matter over Wi-Fi devices lose cloud connectivity immediately and fall back to local-only operation if the controller hub remains powered. But in practice, most Matter ecosystems, Google Home, Apple Home, Amazon Alexa, tightly couple cloud and local control, meaning functionality degrades significantly during router outages, even when the hub has battery backup. Matter over Thread devices fare better. If your border router, like a HomePod Mini, Google Nest Hub Max, or dedicated Thread radio, remains powered via UPS, the Thread mesh continues operating independently of Wi-Fi, maintaining device communication within the local subnet. However, any automation that requires internet access, voice commands, remote notifications, cloud-based scene triggers, stops working until the router restores. The mesh network recovery sequence varies by protocol. Thread reestablishes routing in 10 to 30 seconds. Wi-Fi devices may take 60 to 180 seconds to reconnect and reacquire DHCP leases.
Matter bridges, like Philips Hue or IKEA Dirigera, connected via Matter, require the underlying protocol, Zigbee in those cases, to stabilize before re-exposing devices to Matter controllers. This cascade effect is why protecting your router and modem with a UPS is non-negotiable for reliable smart home operation. The hub alone isn't sufficient.
Should I put my smart home server or NAS on the same UPS as my hub? Only if the combined load stays below 60 to 70% of the UPS's rated capacity, preserving adequate runtime. A typical smart home stack draws 5 to 15 watts for the hub, 25 to 40 for the router and modem, 10 to 20 for a network switch, 30 to 50 for a 2-bay NAS when active. Total, 70 to 125 watts. A 1500 VA 1000-watt UPS comfortably handles this load with 8 to 12 hours of runtime, making single UPS consolidation practical for most installations. The benefit is operational simplicity: one device to monitor, one battery to replace, one potential failure point. However, if your NAS runs resource-intensive services like Plex transcoding, virtual machines, continuous RAID scrubbing, power draw can spike to 80 to 150 watts, cutting runtime by half and risking premature battery depletion before the hub requires shutdown. In those scenarios, separate UPS units allow differentiated runtime targets. The hub UPS sized for maximum duration, 12+ hours, the NAS or server UPS configured for graceful shutdown at 30 to 60 minutes via automated scripts. This segregation also enables load balancing and priority shutdown sequencing. Less critical services power down first, preserving battery reserves for core automation infrastructure. If budget allows only one UPS, prioritize the hub, router, and modem. Configure the NAS for aggressive sleep states during outages. The quiet presence of a UPS under your console, behind cabinetry, or within a dedicated equipment closet shifts a smart home from fragile convenience to resilient infrastructure. Match capacity to actual load. Oversizing wastes budget, undersizing gambles on outage duration, and prioritize pure sine wave output if your ecosystem includes anything beyond basic Wi-Fi plugs. For most multi-protocol households, juggling Zigbee lighting, Z-Wave climate control, and Matter-connected security, the CyberPower CP1500 PFCLD delivers the best balance of clean power, adequate runtime, and integration flexibility. Those with simpler Wi-Fi and Zigbee setups find excellent value in the APC Backup UPS Pro 1500 VA. The automation you've woven into your walls deserves the same thoughtful protection as the architecture itself: invisible, reliable, and always ready when darkness falls. That wraps up this episode of the Smart Home Setup Podcast. Thanks for listening all the way through. New episodes come out every Monday, Wednesday, and Friday, so there's always something fresh waiting for you. If this episode helped you out or answered a question you've been sitting with, I'd really appreciate it if you could leave a 5-star rating and a quick review. It genuinely makes a difference. It's how other people stumbling around trying to solve the same problems you are actually find the show. And if you haven't already, go ahead and subscribe or follow so you get notified the moment a new episode drops. See you next time.